This is a key to the test that you just took. And in number one, you're asked to find the difference quotient for this quadratic function that you see here. Now, I did give you the difference quotient, and so the best way to find the difference quotient of quadratic function using the difference quotient formula is actually do it in steps. So that way, when you do it in steps, it reduces your mathematical errors, and so it should help you. So the first thing you should do is, if you look at the numerator, there are two things that are happening here. You want to find f of x plus h, and then once you find f of x plus h, you want to then subtract f of x from it. So let's look at this part first, and then by the way, at the end, you're going to divide all that by h. So step one for us will be to find f of x plus h. So let's go ahead and list that as step one. So step one, you're going to find f of x plus h. All right, so to find f of x plus h, I go to my function f, which is here, and wherever I see the variable x, I see it here, and I see it here, you're going to substitute this expression x plus h. So this becomes equals 4 times, and remember, you're going to substitute in place of x, you're going to substitute this expression. So it becomes 4 times x plus h squared, okay, minus, subtract, 5 times x, but we're subtracting this, we're substituting that expression, so it'll be 5 times x plus h, that's an h, and then plus 6. Okay, now you got to simplify all of this. So notice here you have two sets of parentheses. In this one, we know that we're going to go ahead and distribute the negative 5 here because x plus h here is being raised to the first power. But over here, we have to use the order of operations. You cannot just distribute a 4 here because that square is being attached to this expression x plus h. So you have to do exponents first. So exponents, then multiplication. So when you square x plus h, and just let's remind ourselves what that is. So whenever you're dealing with these quadratic functions, and we had many to do, some of you already know that when I square x plus h, when I square that, I'm going to get x squared plus 2xh plus h squared. So most of you know that without even having to work it out. But if you do have to work it out, remember what you have to do. Remember, x plus h squared means x plus h times itself. And so when I multiply that, and notice I have two binomials, so when I multiply that using FOIL, I get x times x is x squared. The outer, x times h is xh. And remember, when you square a binomial, the outer and the inner are identical. So x times h and h times x are the same thing. So I'm going to write h times x as xh. And then h times h then becomes h squared. And then combining like terms, and if you notice that these two, the outer and the inner, are like terms, so I get x squared plus 2xh plus h squared. So that is x plus h squared. Now this right here that you see, I'm going to go ahead and now I'm going to put that here. Okay, so this becomes 4 times this thing right here. So this becomes this. Actually this x plus h squared is this. So it becomes, let me go ahead and rewrite it right here. So that becomes 4 times, and I'm going to substitute this now, x squared plus 2xh plus h squared. Okay, and then let's go ahead and distribute this. So I get minus 5x minus 5h plus 6. All right, now distributing the 4, I can do that now. I get 4x squared. 4 times 2xh is 8xh. 4 times h squared is 4h squared minus 5x minus 5h plus 6. All right, so we have this polynomial here, this expression, I should say, and there are no like terms. All right, so let's now remember what I found here was just this little part right here. Now what we're going to do is we're going to take this, what we just found, and we're going to subtract the function from it, which is this quadratic function. So in other words, step 2, you're going to say something like this. You're going to say, now I'm going to find the numerator, which is basically f of x plus h minus f of x. So I found this. That was step 1. So I'm going to write all of this out here now. So I'm going to say 4x squared plus 8xh plus 4h squared minus 5x minus 5h plus 6. All right, so that's this part here. But then remember, you got to subtract your function. So you got to subtract. Now, be careful. Some of you are not putting this in parentheses. So if you don't put it in parentheses, here's what you're going to end up doing. So if you make a mistake, you're going to say this. You're going to say subtract my function, which is 4x squared minus 5x plus 6. But that's not correct. You're not just subtracting 4x squared. You're subtracting all of these terms. You're subtracting this polynomial. So mathematically, you have to put that in parentheses. And now you're going to do one of two things. You can think of this as adding the opposite of each term since you're subtracting, or if you want to, you can think of this as adding a negative 1 times this, so you'll distribute a negative 1. Does not matter. So I'm going to think of this as adding the opposite here. So this becomes 4x squared plus 8xh plus 4h squared minus 5x minus 5h plus 6. And then the opposite of 4x squared is a negative 4x squared. The opposite of a negative 5x is a positive 5x. And the opposite of a positive 6 is a negative 6. All right, and at this point, see, since we're dealing with a polynomial function, at this point, if you did this correctly, every term that doesn't have a factor of h, like this does not have a factor of h in it, its opposite better be here. And so notice it's here, negative 4x squared, a positive 4x squared is 0. This has a factor of h, this has two factors of h, this does not. Negative 5x, here's its opposite, positive 5x. Oops, did the wrong one. All right, so be careful. I did the wrong one. So let me go ahead and kind of white that out. So let me go ahead and do that. All right, so I'm going to go ahead and I just went ahead and I whited this out. So I'm going to go ahead and put it back in. So that was minus 5h. All right, and so negative 5x, here's its opposite, positive 5x. This has a factor of h, this does not, positive 6, and its opposite, negative 6. All right, so what's left should have factors of h. So this becomes 8xh plus 4h squared and minus 5h. Now at this point, you have to remember your factoring expertise, your factoring skills. And so I noticed that these three terms have a factor of h in common. So I'm going to go ahead and take that out. So I get h times 8x plus 4h minus 5. All right, so that's step 2. That's actually your numerator, right? Okay, and so finally, then we're going to take what we just found and divide it by h. So step 3 is actually the difference quotient of this function here. So in other words, you're going to say f of x plus h minus f of x divided by h. So that becomes, so that's your numerator here, right here. So it becomes h times 8x plus 4h minus 5 divided by h. I had to see that, so make sure you see mathematically everything has to be written correctly. And you have to show enough work to get all of those points. So a lot of you, many of you did it just like this, so you showed the work I wanted. Some of you, you're not showing enough work. So I'm not knowing where you're getting some of these expressions without me having to ask you, which I'm not going to do. All right, so make sure you do this. You reduce, and so then you get 8x plus 4h minus 5. And so that's a difference quotient. Now next semester, when you take some form of calculus, you're going to delve more into what this difference quotient means. So right now, though, you just know how to find it, and this is it right here for this function. So as you remember, given a particular function, the difference quotient will not look the same, but you're going to use the same formula. All right, and so the answer is 8x plus 4h minus 5. All right, so that was number 1. Okay, now number 2. In number 2, you started out with a piecewise function. And so this function g of x is made up of 3 pieces. And these are the domains for each of those pieces. And so in letter A, I'm going to go ahead and do that here. So in letter A, you want to find g of negative 6. So you want to go to your function g, but you got to determine which one you're going to use, right? You can't use all three. You have to use one of them. And so the one you're going to use is dependent on whatever that value is right here. That value here is a negative 6. So I got to find the one here where that's in my domain. So the the function g of x equals 3x minus 7, I'm going to use that if my domain is greater than 2. But that's a negative 6. Negative 6 is not greater than 2, and negative 6 does not equal 2, but negative 6 is less than 2, right? So this is what I'm going to use. So I'm going to go ahead and write that here. I'm going to use 2 minus 5x. All right, so where we see the variable x, I'm going to substitute negative 6. So that becomes 2 minus 5 times negative 6. So order of operations, a negative 5 times a negative 6 is 30. 2 plus 30 is 32. So that's letter A. So get 32 here. Letter B, I'm going to go ahead and do that here. You want to find g of 2. Okay, so we're going to go through the same thing. So I got to use one of these, and that's dependent on what this value is. This value is 2, and the only one that fits here is this one here. So 2 equals 2. 2 is not greater than 2, and 2 is not less than 2, but 2 equals 2. So I'm going to use this function. So we're going to use negative 3x squared. So in place of x, I'm going to substitute 2. So this becomes 3 times 2 squared. 2 squared, I'm sorry, negative 3. Be careful. Negative 3 times 2 squared. 2 squared is 4. And negative 3 times 4 is a negative 12. So that's going to go here. All right, letter C. I'm going to go ahead and put letter C right here. You want to find g of 5. So obviously you're going to know that you're going to use this one right here because 5 is greater than 2. So I'm going to use 3x minus 7. So that becomes 3 times 5 minus 7. So that's 15 minus 7, which is 8. So g of 5 is 8. G of negative 1, let's go ahead and do that here. So g of negative 1, you know that negative 1 is not greater than 2. Negative 1 does not equal 2, but negative 1 is less than 2. And so when x is negative 1, I'm going to go ahead and use this function, 2 minus 5x. So it becomes 2 minus 5 times negative 1. So that's 2. Negative 5 times negative 1 is plus 5. And 2 plus 5 is 7. All right. Number 3, you want to find the average rate of change of the following function here over this interval. Remember, that's an interval. That's not a point. And so what I expected you to show was something like this. So the average rate of change, and then I needed to see this. I needed all of you to show me. Remember, the average rate of change is the idea of the slope. And so in that interval, you could have said something like, remember this is your function g, so you could have said something like g of 6 minus g of negative 3. So the change in y values, so you're going to get those y values, and then divided by the change in x. And those x values are these x values here. So you're going to say 6 minus a negative 3. Someone else could have said, I'm going to go ahead and do that here. Someone else could have said, instead of saying g of 6 first, someone else could have said g of negative 3, subtract g of 6 divided by. But if you're going to find this y value first, then you have to put negative 3 in the denominator first. So negative 3, so you're subtracting your x coordinates. So negative 3 subtract 6. But whichever one you use, you're going to end up with the same answer in the end. All right. So now if you could do this, now I had to see this, and so I also had to see some work. So you have to tell me what g of 6 is. So g of 6, I'm going to go to my function g, and wherever we see the variable x, and that's the x squared right here, wherever we see the variable x, you're going to substitute 6. So you're going to say 2 times 6 minus 3 times 6 squared, and then 2 times 6 is 12, subtract. Now to do this one, you're going to square the 6 first, and so you may need to use your calculator. Let's see. All right, so I went ahead and I got my calculator. So those of you with a calculator, you're going to say something like this. You're going to say 6 squared is 36, right? And then you say times 3. And so you get 108. So you can say 12 minus 108. And so 12 minus 108 is going to equal 96, negative 96. So that's g of 6. So I had to see how you got negative 96. So now we have negative 96 here. And I'm going to subtract g of negative 3. So let's figure out what g of negative 3 is. So I'm going to do the same thing. I'm going to go to my function g, and wherever we see the variable x, I'm going to substitute negative 3. So I get 2 times negative 3 minus 3 times negative 3 squared. 2 times negative 3 is a negative 6. Subtract. Negative 3 times itself is 9. 9 times 3 is 27, right? And so you have a negative 6 and a negative 27. Now, if you're not very confident doing that in your head, use your calculator. You have access to a calculator. So say negative 6, subtract 27, and you'll get negative 33. All right, now that's g of negative 3. I had to see that. I had to see where that came from. And then all of that's being divided by, now remember 6 subtract a negative 3 means 6 plus the opposite of a negative 3. So that's 6 plus 3. So a negative 96 and a negative 33 will give you 100, oops, let's do it again. Negative 96 plus 33, okay, 129. So it'll be negative 129 divided by 9, right? And so let's see what we get. 129 divided by 9. All right, so that's not the correct answer, so I did something wrong. So let me go back and figure out what I did wrong here. Let's see. All right, so I figured out where my error is. So all of this is correct, but remember you can easily make a mistake, right? Because this says subtract, but remember g of negative 3 is not 33. What's g of negative 3? G of negative 3 is a negative 33, so I have to be careful, right? Okay, so let's go ahead and do this over. So this becomes negative 96 subtract a negative 33 means negative 96 plus 33 divided by 9. And negative 96 plus 33, use your calculator if you have to. Negative 96 plus 33 equals a negative 63, right? So you get negative 63 divided by 9. And negative 63 divided by 9 is a negative 7. So the answer here is negative 7. All right, so that was number 3. Okay, so let's look at number 4. So number 4, you have these two functions, and you want to find these two operations here. Now notice here you want to find g plus f evaluated at 2. Now remember whenever you're evaluating at a number, you're going to end up with a number. Here I'm evaluating at a variable x. I'm going to end up with a variable expression. All right, so remember what this means. G plus f at 2 means g of 2 plus f of 2. And so now I'm going to go and I'm going to find each of these. So g of 2. So g of 2 means I go to my function g, so make sure you're using the right one. And wherever you see the variable x, you're going to substitute 2. So I'm going to go to this quadratic function here. That's g. So I get negative 3 times 2 squared minus 4 times 2 plus 8. All right, order of operations, 2 squared is 4. 4 times negative 3 is a negative 12. Negative 4 times 2 is a negative 8, and then plus 8. And so when you add these up, you're going to get a negative 12. So g of 2 is a negative 12. So that's going to go here, negative 12. So that's just right here. I'm going to add to negative 12 whatever f of 2 is. So you have to show the work, f of 2. You're going to go to your function f, and wherever you see the variable x, you can substitute 2. So I get 3 times 2 minus 4. 3 times 2 is 6. 6 minus 4 is 2. So that's f of 2. So now I get negative 12 plus 2, which is a negative 10. So that goes here. Over here, you want to find f subtract g at x. By definition, that means f of x subtract g of x. Remember, the order matters with subtraction. Subtraction is not commutative. So over here, it did not matter whether you put f of 2 or g of 2 here first. But here it does matter. So f of x subtract g of x. You put in that order, the order in which you see it. So f of x is, see how we had to do some work here to find each of those? Here you don't have to. This is actually easier than this. You can make a mistake here easier than you can make a mistake here. F of x is this linear function, so I'm going to put that here. So f of x is this function, this expression, 3x minus 4. I'm going to subtract, and remember that's subtraction, so you got to be careful. I'm going to subtract g of x, which is this quadratic function here. So I'm going to put that in parentheses. So I'm going to subtract all of this. So we talked about that earlier, about how important that parentheses is. So 3x squared minus 4x plus 8. Now we got to get rid of the parentheses, so I'm going to add the opposite, right? And so I'm going to put equal sign here. So I'm going to get 3x minus 4. The opposite of a negative 3x squared is a positive 3x squared. The opposite of a negative 4x is a positive 4x. And the opposite of a positive 8 is a negative 8. And then combining like terms and putting it in descending order, I'm going to get 3x squared. 3x and a positive 4x is a positive 7x. A negative 4 and a negative 8 is a negative 12. So that goes here. 3x squared plus 7x minus 12. All right, so that's number 4. Okay, and number 5, we are still dealing with the algebra functions here. So you have two different functions, and in part A, you want to find negative 3 times, remember that little closed dot here means multiplication, so times g of 2. So I got to figure out what g of 2 is first. And so let's go off to the side and figure out what that is. Show the work. So figure out what that is. So g of 2, make sure you use the right function, g of x here. So it becomes 3 times 2 plus 7. 3 times 2 is 6, and 6 plus 7 is 13. So that goes here. So that becomes negative 3 times 13, and negative 3 times 13 is a negative 39. Okay, B, you want to find f times g of x. By definition, that means f of x times g of x. So f of x is this function here, and g of x is this function here. Now here's where some of you are going to make a mistake. So some of you are going to say, well, that is 4x minus 5 times, and that is, g of x here is 3x plus 7. And so if you're not careful, you're going to think, well, I just need to multiply these two together and then combine like terms. That's not what that is. That is saying I'm going to take all of f of x, parentheses, and I'm going to take all of g of x, parentheses, and multiply those together. And now you'll notice, you'll recognize, hey, those are two binomials I'm multiplying together, so I can use the FOIL method. So notice how important parentheses are, and you have to know when and how to use them. All right, so let's go and use a FOIL method. So 4x times 3x is 12x squared. The outer 4x times 7 is 28x. The inner negative 5 times 3x is a negative 15x. And a negative 5 times 7 is a negative 35. Combining like terms, I get 12x squared, 28x, and a negative 15x is a positive 13x, and then minus 35. And that's it. So there's your answer. 12x squared plus 13x minus 35. All right, number 6. So in number 6, this time, and we spoke of that before, see that's an open circle. So when you see this open circle, that means composition. That does not mean multiplication. And you have to know how to rewrite a composition into a way that you can manipulate it. So meaning this, you have to know that f composed with g evaluated at 3 means this. Means f of g of 3. That's what you have to recognize. And so therefore, we always do the innermost part first. I need to find what g of 3 is. So remember, composition means you take one function and you put it inside of another, which is what's happening here. So let's go ahead and find g of 3. So g of 3, I'm going to go to my function g, which is this quadratic function. And wherever I see the variable x, I'm going to substitute 3. So it becomes 3 times 3 squared plus 5 times 3 minus 1. Order of operations, 3 squared is 9, 9 times 3 is 27, 5 times 3 is 15, and subtract 1. So use your calculator if you need to. 27 plus 20, 27 plus 15, subtract 1 gives you 41. So g of 3 is 41. So that goes here. So that's what I just found, g of 3. So now I'm going to take 41 and I'm going to put it inside function f. So that's what this means. And so now I'm going to go to my function f, which is this linear function. And wherever I see the variable x, I'm going to substitute 41. So the 41 then becomes 4 times 41 plus 3. And then multiplication before addition. So 4 times 41 is going to equal 164. And so 164 plus 3 is 167. See the work? All right, so make sure you know how to show the work and how to manipulate expressions. Okay, so remember when you evaluate a function at a number, you end up with a number. When you evaluate a function at a variable, you get a variable expression. All right, now remember what this means. G composed of f of x means, by definition, means g of f of x. All right, now I know what f of x is. F of x, remember, is this linear function. So I'm going to write that here. F of x is 4x plus 3. So in place of f of x, I'm going to substitute this. So this becomes g of 4x plus 3. So now that means I go to my function g, and which is this. G of x is 3x squared plus 5x minus 1. So I go to my function g, and wherever we see the variable x, I'm going to substitute 4x plus 3. So what I needed to see at this point is this. I needed to see this. I need to see 3 times, and then in place of x, you substitute 4x plus 3. And I'm squaring that. Then plus 5 times 4x plus 3. And then subtract 1. So that I had to see. Then you have to do some work, right? So we got to figure out, well, first of all, what is 4x plus 3 times itself? So that's not difficult to do. So that's you're gonna utilize the FOIL method here, because 4x plus 3 times itself means this. And so 4x times 4x is 16x squared. The outer 4x times 3 is 12x. And remember, when you square a binomial, the outer and the inner are always going to be the same. So 4x times 3 and 3 times 4x are both the same as 12x. And then 3 times 3 is 9. Combining like terms, I get 16x squared. 12x and 12x is 24x, and then plus 9. Now that is this. So I'm going to put that here. So that becomes 3 times 16x squared plus 24x plus 9. Now at this point, I'm going to go ahead and distribute here. So I get plus 20x plus 15 and then minus 1. Now I'll go ahead and distributing here. 16 times 3 is going to be 48x squared. 16x squared times 3 is 48x squared. 3 times 24x is going to be 72x. And then 3 times 9 is 27. And then plus 20x plus 15 minus 1. And then combining like terms, I get 48x squared. 72x plus 20x is 92x, right? And then 27 plus 15 minus 1, use your calculator if you have to. 27 plus 15 minus 1 equals 41. Positive 41. And that's your answer. So g composed with f at x is 48x squared plus 92x plus 41. Number 7. Number 7 is an easy problem to get, so those are easy points. You just have to know how to utilize the table. So again, notice I'm dealing with composition. So f composed with g of 3 means f of g of 3. Then we're going to find g of 3. So g of 3 means what's my y value when x is 3, right? So remember, f of x means y, g of x means y. And here's your x. So when x is 3, so you find where x is 3, that's this one right here. So that's this row. So when x is 3, the question is, what is g of 3? Well, g of 3 is a negative 4. So then this becomes f of negative 4. And so f of negative 4 means, what is my y value when x is negative 4? So I go and I find x is negative 4. That's this one. So my y value when x is negative 4 for f, so f of negative 4 is 2. So the answer is 2. That goes here. The next one, g composed with f at 1, means g of f of 1. And so I do the same thing. So when x is 1, what's my y value for my function f? So when x is 1, that's this one, f of 1 is negative 4. So it becomes g of negative 4. And then I got to find g of negative 4. So what's my y value when x is negative 4? So when x is negative 4, g of negative 4 is 5. My y value is 5. So that becomes 5 here. F composed with f at negative 2. So that means f of negative 2. So I do the innermost first. So when x is negative 2, what's my y value? So in other words, what's f of negative 2? So when x is negative 2, f of negative 2 is 3. So this becomes f of 3. Then f of 3 means what's my y value when x is 3? So when x is 3, f of 3 is negative 8. And so the answer is negative 8. This one, that becomes f of g of negative 2. So g of negative 2 means what's my y value when x is negative 2? So when x is negative 2, g of negative 2 is 1. My y value is 1. So now I'm going to find f of 1. So g of negative 2 is 1. So I'm going to take 1, put inside of f. So now f of 1, when x is 1, f of 1 is negative 4. So the answer is negative 4. And so that's how you do that one. So that was number 7. All right, and then number 8 had 2 parts. And so part A did not require any work, but part B did. So let's look at the part A. So part A, you're given this function, f of x plus 5 squared plus 7. And so basically, I wanted you to use the idea of transformations to tell me how to go from the parent function x squared to f of x. How could I get this function here from my parent function x squared? So remember when we talked about this, you had some videos to look at to help you with this, concept. So you always go from left to right. Now remember, when the numbers inside the parent function, you gotta think counterintuitive. So when the numbers on the inside, that's a horizontal translation. The numbers on the outside, that's a vertical. So this involves a horizontal translation and it involves a vertical translation. Okay? And so the horizontal, don't say I'm shifting x squared to the right 5 units. You got to think counterintuitive that you're actually shifting it to the left 5 units. So that's going to be to the left 5 units. And the vertical translation, the vertical shift up and down, that's intuitive. So see how you see this plus 7? So that means you're going up 7. This was minus 7, be going down 7. So then once you take x squared and you shift to the left 5 units, then you're going to shift it up 7 units. And so the one that's going to work here will be, I think it's, let's see, left 5 units and up 7 units. So that's B. Okay? All right, now in part B, you're given this polynomial function that's actually f of x equal 2x cubed minus 5x. And you want to determine algebraically, so you have to show that work, if the function's even, odd, or neither. And I gave you a hint. And I went ahead and I said, find f of negative x. All right? And so first thing you have to do, remember this was 5 points, and so you could get a lot of your points by just using that hint. So f of negative x means I go to my function f, and wherever I see the variable x, I substitute negative x. So that becomes 2 times negative x cubed minus 5 times negative x. Now, remember, um, negative x, now you got to simplify all this now. So remember, negative x cubed means negative x times negative x times negative x. So negative x times negative x is a positive x squared, and then x squared times a negative x is a negative x cubed. All right, so that's what this is. So this becomes 2 times negative x cubed. So negative x in parentheses cubed means the same thing as negative x cubed without parentheses. Now we had to go ahead and put in parentheses and multiply it by 2. Over here, negative 5 times a negative x is a positive 5x. Now, getting rid of these parentheses that I've inserted, 2 times a negative 1 is a negative 2, and a negative 2 times x cubed is a negative 2x cubed. All right, and that is f of negative x. All right, so that's the first thing you have to do. Then you have to compare that with f of x. So now we're going to compare f of negative x with f of x. All right, so here is f of negative x. So f of negative x is negative 2x cubed plus 5x. F of x is 2x cubed minus 5x. And so the idea is this. So you're comparing them now. So you're asking yourself, are those two functions that I see here equal to each other? And the answer is no. This is negative 2x cubed, this is positive 2x cubed, this is positive 5x, this is negative 5x. So it's not even. So not even, since f of negative x does not equal f of x. They're not equal to each other. Then the question is, are they odd? Well, remember, in order for two functions to be odd, in order for this function here to be odd, when you look at f of negative x and f of x must be opposites of each other. So are these two expressions here opposites of each other? In other words, is f of negative x and f of x opposites? And the answer is yes. Negative 2x cubed, positive 2x cubed. Positive 5x, negative 5x. That means when you graph this function, it's going to be symmetrical about the origin. Remember, an odd function, symmetrical about the origin. And so you're going to say it is odd. The answer is odd since f of x is the opposite of f of negative x. Another way you could say that is this: f of negative x equals the opposite of f of x. In other words, written like this. Okay? All right, so that was part B. Number 9, we have this. So you're given this graph right here. So it was these were actually easy problems to do. And you want to state the domain. So remember, the domain is a set of x values, set of x coordinates. So when I look at every point on this graph, as I go from along this graph, remember there are two arrows here, one going up, one going to the left, to the right. So as I go along the graph, I need to look at all those x values. What are these x values taking on? So basically, you're going to go from along the x-axis with a ruler. We use the idea of a ruler. So this is keep going this way, right? So that you're going from negative infinity all the way. When we look at all these x values, you're going all the way to positive infinity. So the domain's negative infinity to positive infinity. So every x value you see here is going to take on any real number. Then you want to state the range. So the range is a set of y values. Now remember, you got to look at all these points and ask yourself, what are my y values obtaining? What are those y values? So to help you, it's always best to go along the y-axis. And notice when I go along the y-axis, I start touching the graph when y is negative 4. So that means that y equal negative 4 is going to be my smallest number in my range, smallest y value. And so since negative 4, all these are closed circles, you're going to say from negative 4 all the way. Now don't stop here because remember this thing keeps going up. So you're going from negative 4 bracket all the way to infinity. So the answer there should have been bracket negative 4 to infinity. All right. Now, indicate the intervals where the function is constant. So remember, as I go from left to right, remember when you talk about the intervals where the function is constant, the idea of the function being constant, you got to go from left to right. And as I go from left to right, you're looking at those y values. These y values here are decreasing. Then my y values are constant. You can see they're all equal to negative 4. And then my y values are increasing, and then my y values are constant. All these y values here is equal to 2. So there are two intervals that you're going to put here. So there are two intervals where my function is constant. But the intervals that you put is the domain. So you got to look at what those x values are. So it might help if where you see it's constant, which sees where it starts here, you kind of put a line here to help you. So it's constant from when x is negative 7 to, and then when x is negative 2, right? And then it's constant from x equal 1 to x equal infinity. So the answer is going to be, and remember when you talk about increasing, decreasing, or constant, it's always over an open interval, meaning all parentheses. So you can say negative 7 to negative 2 parentheses, union, and then 1 to infinity. And then where's a function decreasing? There's only one place where it's decreasing, and that's here. You had to recognize that was an arrow, so you're actually going from negative infinity to this x value being negative 7. So you're going to say negative infinity to negative 7 parentheses. Then you want to find g of 800. Now, that was not supposed to be a difficult item. So if you look at this, g of 2, see all this is constant, right? My function's constant. So remember what that means. That means no matter which of these x values, which of these points you're looking at, my y value is 2. That's what that means. So in other words, when x is 7, my y value is 2. When x is 10, right here, my y value is 2. So when x is, let's say, 800, my y value is going to be 2. So the answer is 2. So what is the y value when x is 800? The answer is 2. All right. Number 10, you're given this function, and you want to state the range. So remember, the range is a set of y coordinates. Notice these arrows are pointing down. So you're looking at all these points, and you're asking yourself, what are those y values? And so basically going from negative infinity, and then when you go up, the graph actually stops here, which is at y equal 5. So the range, you're going to say negative infinity to 5 with a bracket. Where's the function increasing? So there are two places where my function is increasing. So it's increasing here, decreasing, increasing, decreasing, right? So it's increasing from negative infinity. So it's increasing from negative infinity to this x value, which is negative 6. And then it's increasing from here, which is x equals 0, to here, which is x equal 6. So from negative infinity to x equal negative 6, and from 0 to 6. So that's where it's increasing. Negative infinity to negative 6, union, and then 0 to 6. Okay? And then what's the local minimum value? So remember, this is a continuous polynomial function. And so it's very easy to determine minimum maximum points. So that's where they go from increasing to decreasing or decreasing to increasing. So see where you go here from increasing to decreasing, this will be a local max. Then you go from decreasing to increasing, so this is going to be a local min. And then you're going from increasing to decreasing, so this point here will be a local max. Okay? But I'm asking this, what's the local minimum value? So when I ask about the local minimum value, I'm talking about the y value. So if this is my local minimum point here, what is that y value? Well, that's the origin in it. So that's the origin, 0, 0. So my local minimum value is 0. So I needed to see 0 there. Now, I gave you a hint here because I knew this was going to be confusing for you because there are 2 points that are local maximums and they both have the same y value. So you see this point here is negative 6, 5. That's a negative 6. And this point here is 6, 5. And so there are 2 local maximum points in the graph. What is the local maximum value? So there's only one answer I needed there, and that was for you to recognize that both of these values are 5, so you're just going to say 5. And then here is a function even, odd, or neither. You should have recognized that this is an even function because if you take this piece right here, remember an even function is symmetrical about the y-axis. So if you take this piece here reflected about the y-axis, you get that. And if you take this piece here reflected about the y-axis, you get this. All right. So just by looking at the graph, you should have recognized that was an even function. None of you should have said odd because odd function means it's symmetrical about the origin. If you look at this point reflected by the origin, there's no point here. Okay, so you knew it couldn't be odd. Same thing here. Take that, reflected about the origin, that you don't get a point here. Okay, so all these should have been, if it was odd, should have been reflected about the origin. You would have gotten a point on that graph, and you don't. So the answer here is even. So when you reflected about, remember when you take a point of the, so if a function is symmetrical about the y-axis, meaning it's even, so this is an even function, that means that if you see the point 6, 5, which you see here, then the other point on the graph should be negative 6, 5. So the y values, so when you reflect about the y-axis, the y values stay the same, the x coordinates are opposites. So if you take this point here, let me see if I can find one that's right here. So let's say this point here is 4, 3. When you reflect it about the y-axis, you should get the point negative 4, 3. And I didn't draw it very well, but you would have gotten this point here, negative 4, 3. Okay? All right. Okay, so that is your the key to the test that you just took.